Hello fixers, today we're going to be making a simple Atari 2600 cartridge. We'll design a custom label with the help of some AI artwork, and we'll even 3D print a cartridge shell using a resin printer. And we're going to do it right now.
Mark fixes stuff. This video is sponsored by PCB. You can get an instant quote on a variety of services, or browse a library of talented makers' designs, add them to your cart, and have them delivered directly to your door.
This simple cartridge board was designed by Parker Dillman, aka the Longhorn Engineer. It's a really simple build with only a few components. There's a socket for your 2 or 4K EPROM, a small piece of logic, and a solid state capacitor. Even I can't muck this up, or can I? Anyway, let me tell you about my new toy that has absolutely nothing to do with any Japanese octopus stroke tentacle cartoons. It's a real time-saving device, meant to hold things whilst you're soldering, and look how easy it is to use. You simply clip one side of the PCB into one of the arms, and it's a doddle to clip one of the other highly flexible arms on the other side. Once your PCB is securely clamped, just rotate these two custom designed grips so you can see the back side of the board. Honestly, this is such a time-saving device, I don't know how I ever lived without it. We need to install our logic chip, making sure to observe the chip notch marking and the square pad for pin 1 of the IC. The 7404 chip is a hex inverter containing 6 inverting NOT gates. Terry and Dave are in the house, judging me with all the gelatinous joy that only the gooey gummy gang can muster. Before I solder in the logic, I'm going to turn down the pins on the corner to stop it dropping out of the board. And before anybody moans that I'm not socketing this IC, there's no space for a socket. I also did a simple vector test using my EPROM burner and it passed. So I think we're okay. This tentacle holder thing really is bloody awful, but I've committed to it now, so we'll keep using it. Don't forget when soldering to heat the pad and the leg of the component at the same time for equal solder flow. Okay, not the greatest soldering, but I'm trying to do this fairly quickly. And I think that looks okay. With our hex inverter installed, we need to install this capacitor next. The capacitance value is 0.1 microfarads, otherwise expressed as 100 nanofarads. These aren't polarised, so you can pop them in the board any way round you like. Components with this style of legs with the kinks are meant to hold in the board whilst you're soldering them. I never seem to have very good luck with them though. You'll also notice in the background my solder fume extractor. I've had this all along, but people kept moaning I wasn't using one, so I've moved it into camera shot. I'm using my larger Pros Kit cutters here because they don't fire the cut leads into my flesh like tiny javelins. Some would call that a plus. Next we need to install this incredibly cheap 24 pin wide socket. And we need to manage our expectations because we're not going to be able to get it flush to the board because of the soldering work we've done on the components mounted on the other side of the PCB. Sure, I could go and clip them down flush to the board, but time is short and so are hobbits. And as I predicted, the capacitor moved whilst I was trying to solder it. But like myself, it's ugly but functional. Turning down the corners on the socket so it doesn't fall out of the holes, we prepare for soldering. That will do, I think, although I am conscious that it's not flat to the board. I'm sure it'll be fine though. At least it's evenly uneven on both sides. If that's a thing. When soldering a socket, you have to be careful not to melt the plastic, and that can be a bit problematic when you're on a ground plane where you have to put quite a lot of heat into the board. You can end up with some blobby joints. Some people recommend popping the EPROM into the socket, that way you can warm the component instead of melting the socket. I'm not sure how I feel about that. Okay, so the socket's in and it's looking pretty good. In fact, that's the whole board put together. Didn't take long at all, did it? Now this board is very simple and it's only suitable for a 2K or a 4K game. As such, we'll be using a piece of homebrew called Island Run by the Durabun, otherwise known as John Eugenio. Whilst we're getting on with other tasks, I thought it might be a good idea to get the 3D printing of the shell underway. I've printed quite a lot of cartridge shells using FDM printers. That's the type that has a spool of filament and heats it through a nozzle, like hot toothpaste, building up one layer at a time. I thought it might be a good experiment to see if we could print a cartridge shell using a resin printer. One of the things about resin printers is they are suspended from a build plate that's upside down in a vat of resin. An LCD screen turns on and off, and then a UV light exposes itself to the resin to build up the layers one layer at a time again, but this time using light instead of heat. Because of this, it needs supports, and those supports need to be placed quite judiciously. This software is called Chitubox, and it can place the supports automatically, but it tends to put them on the surfaces that I want to look nice. Unfortunately, supports leave pop marks when you remove them, so I spent about an hour manually supporting this model. Conversely, I don't really care how this insert looks. I've just whacked it on the build plate and done some auto supports. And it hasn't made a bad job of it, to be honest. Let's go over to the resin printing table. This Elegoo Mars 3 printer was kindly donated to the channel by Elegoo themselves, and I've filled it with engineering type resin. The resins used in 3D printing are not good for your skin or your lungs, so please make sure you use gloves, a respirator, and something to protect your eyes. Having copied the first half of our cart shell to our thumb drive as a CTB file, we kick off the print. There's something quite majestic about that platform being lowered into the resin. We really are living in the future. Let's leave this to print. Of course, one thing we will need is the program on our EPROM, and that's where we hit a bit of a snag. The M2732A EPROM we're using needs a programming voltage of 21 volts. And my EPROM burner maxes out at 18 volts programming voltage. Not good. So I've added a switch that adds an extra 7 volts on top of whatever the software says it's supplying to the EPROM. If you'd like me to show this simple mod in a video, then let me know below. I found the details on the EEV blog forums, link below. There is an additional quirk with the 2732 EPROM. During the read and write process, the CE line should be pulsed low. For some reason, the CE line goes high during writes, but this can be fixed by tying pin 18 or the CE line to ground. It's a bit hacky, but it forces the CE line to be low always during reads and writes, and allows us to program our EPROM. We'll pick 14 volts and make sure that our switch is in the on position, and 14 plus 7 equals 21, which then allows us to write our EPROM. Great success. I do need to tidy up this little mod, but I'm quite happy that I didn't have to buy another EPROM programmer. After that, it's quite the relief to insert the EPROM into our board. Lovely. I'm quite happy with that. You may have seen one of my previous videos where I made an Atari 2600 cartridge label template. I decided to use that as the basis for a new label for our game, and I used a piece of AI art generated from openart.ai. I used the prompt male Indiana Jones style adventurer running from left to right across an island, natives chasing, airbrush style, 1970s video game art. And whilst I didn't get running from left to right with the natives chasing, it didn't make a bad fist of it. Hiding that layer, you can actually see my template underneath. I have layers for the Atari logo and the CX number of the game. And we're not going to need either of those here. It's just a matter of turning off visibility of the layer. And the same for the CX number. And now, the gallery. I actually think this looks alright. Things that AI can churn out are pretty nuts, I think. And if it ever learns how to do limbs or hands, we're screwed. Back at our 3D printer, the first part of our resin printed shell has finished. As a kid born in the 70s and growing up in the 80s, I've got to tell you, things like this absolutely blow my mind. I'm literally printing objects. And on first glance, it looks like it's come out okay. The first part of my process for dealing with resin prints is to slip it into my dirty bucket. The IPA in here is really filthy, but it saves me getting my wash and cure station extra dirty. Also, not forgetting this little doobry, this can go in at the same time. Popping the lid on, it's time to give our mucky parts a good wash. Now I can't overstate the importance of safety. Resin fumes can affect your lungs, and the resin itself is bad for your skin and your eyes, so wear eye protection and gloves at all times. And by all times I mean at all times. I wear mine down the pub, and also during coitus. Follow my example everyone and stay safe. Once our parts have been suitably washed, it's time for them to be exposed to UV light. This is called curing and causes the resin to harden. Just to hammer that safety message home, you shouldn't handle any uncured parts without gloves. Curing resin prints is far from an exact science. Different resins take different amounts of time to cure, and you're often found looking at forums and spreadsheets to try and find out an appropriate curing time for your resin. Whilst the second half of our cartridge shell is printing, I thought it would be a good idea to get on, print out and cut out our cartridge label. For this we're going to be using a Cricut Explore 3. Cricut machines come with a piece of software called Design Space. I'm not the biggest fan of this. It's proprietary and really locked down. The interface is really 2005, and the main thrust of the software seems to be to get you to buy a subscription to their marketplace. That being said, you can import an image with transparency, set it to the right size, which this clearly isn't, and then print and cut it out. With our label set to the correct dimensions, we just need to press that make button. On the next screen we see how our job will be organised. It's telling us we need to take our sheet of A4 sticker paper and pop it onto a 12" by 12" sticky mat. Then we'll proceed, and that will bring up the printing setup dialog. Now I'm using my Epson EcoTank 8550. This is a photo printer, so it should come out great. We're also going to add bleed, which adds a little border around the image, an extra margin of safety just in case the cut is slightly off. I select to use the system dialog and press print. Going into the Epson system dialog gives us another level of control. I've already set up photo stickers in the driver, so I don't need to change things like paper source, paper type or colour type, although I have set it to 3 copies for some weird reason. With that all selected, we click OK. Now let's go over to the printer itself. We're going to need to put a sheet of sticker paper into the rear tray. I'm using this chroma paper. It's okay. It's not the best I've ever used, but I've run out of my favourite stuff. By the way, my favourite stuff is Ice Professional Photo Paper. Photo paper needs to go into the rear paper feeder. That's because the coating on photo paper sticks to other photo paper, so it can't go into the paper cassette. I do sometimes wonder if this printer would give Sigourney Weaver flashbacks. Nah, no one's going to get that reference. Another issue I have with the Cricut Design Space software is it doesn't understand colour profiles. I would have preferred printing this from my colour managed Photoshop setup. Alas, it's not possible if you then want to go on and cut it out. Well, not using official methods anyway. For the base material we select gloss sticker paper with a kiss cut. A kiss cut is where it just cuts through the paper of the sticker and not the backing. It also enables you to rock and roll all night and party every day. I'm going to select more pressure here because I know that the paper needs it. Once that's done, the Cricut software tells us what tools we need in what clamps. Mine are already loaded, so let's go over to the Cricut machine itself. To use anything other than the expensive Cricut materials, you need to place them on one of these cutting mats. They've got a semi-tacky surface, so when we put our page on we line it up to the grid as accurately as possible and then just smooth it down. With our sheet in place, we load the cutting mat into the Cricut and press the feed button. The Cricut uses an optical sensor to go and determine what you've loaded into it. Once it knows, it positions the mat at the start position and flashes the play button at you. At least I think it's a play button, it looks like one. And what can you do with the play button, apart from press it? The Cricut sets about reading the registration marks that have been printed around our image. If we had several stickers, the registration marks would be on the outside of all of them, although annoyingly you can't use the entire sheet of A4 paper. And here's our Island Run sticker, kiss cut and ready for our cartridge. Back over on the workbench, we've got the electronics for our cartridge ready to go into the shell. We have the front of our cartridge and the back of our cartridge. We also have our, whatever that's called. I have noticed something. This resin, when you use it to print a large thing, it's actually really flexible, which isn't really what I was after. If I'm printing a small cog, perhaps a couple of millimeters across, this flexibility is really useful because it stops the resin print from shattering. But over the span of a larger part, that give, well, it seems to translate to warping and being a bit rubbery. There's also a bit of deformation along the flat edges. It's present on both the sides. You can flex this material and it doesn't seem to break. Regardless of all the problems, I think it's dimensionally accurate enough for us to install our electronics. But I've hit another problem. This socket means that the EPROM is too high to fit into the case. Hooray! Ever wish you hadn't started something? I reckon this is around 2 or 3 millimeters too high, so unfortunately this means just one thing. Desoldering the socket, and then soldering the EPROM straight into the board. Luckily, I've got a desoldering station which makes fairly short work of this task. I hope you're enjoying this video, and why wouldn't you be? A good looking, amazing person like you. Maybe you consider becoming a patron of MarkFix's stuff. You'd be helping me to create future videos, but you'd also get ad-free early access to all my stuff. There's also Patron exclusive behind the scenes posts, and a recent study said that MarkFix's stuff patrons are amongst some of the sexiest people on the entire planet. So there is that. If you want to become a patron of MarkFix's stuff, come along to patreon.com/MarkFix's stuff, and I'll see you there. Thank you so much. Because this is a fresh board, once we've desoldered all the pins, it's fairly trivial to make sure they're no longer stuck to the sides of the wires. And with the wires all freed, we'll be able to pull the socket out of the board. I prefer a levering motion, and I tend to use these tweezers. This really wasn't half as difficult as I thought it was going to be. Hooray for us! And the PCB seems to have survived intact as well. Thanks PCBWay. This EPROM now needs to go into the board, so we remove it from the socket. Even the socket seems to have survived, so I think I've saved upwards of about 32 pence here. Honestly, this went in first time, and I didn't have to do 15 takes to try and get it in and then edit out all the flubs. Hooray, it's time for even more soldering. Grab our solder, grab our hot tool, and get down to it. It's actually much easier to solder an EPROM into a board than it is a socket. The solder flows so easily down the pin of the chip. Apologies for the knuckles. It's hard to work around the camera sometimes. Notice how you can see the flux fumes being sucked off towards the fume extractor. Well, that's proof it works if nothing else. All done. And look, it fits. Although I've noticed another problem. There's too much lateral motion. I'm going to use some 2-part epoxy resin. which only comes out of one side of the glue dispenser. Annoying. And now it's going everywhere. Awesome. Absolutely amazing. Wish I'd never started this project, really. A couple of blobs of epoxy should hold this nicely though. The good thing about epoxy resin is when it sets it has a slight amount of give, so it doesn't become brittle like superglue and snap off. There we go, nice and tidy, even after I've made a mess of the desk. Should have fitted this first though. Whoa, another flub. Give me strength. Right, by hook or by crook, I'm going to get this cartridge working. Now the epoxy resin is on the shell, it's easier to see the lateral shift I was talking about, but the resin should solve that. Pro tip, using the glue you've got left behind on the bit of cardboard, you can tell when the resin has set, because when it's set on the cardboard, it's going to be set on your project. And it's set on the cardboard. My goodness, it's set on the cardboard. And it's really set in the shell as well. Totally rigid. Awesome. Let's pop the other side on. I have got serious misgivings about this project now. It's looking very, very shonky. But at last we get to do some screwing. We're going to use some of these M3 screws. They're self-tapping. That means they'll cut their own thread into our resin print. And we're going to use the 12mm ones. We'll need 4. It really is a simple case of just screwing them into the hole. The screws take in quite well. Trying to keep the case aligned, I move on to the next hole. And that really bit quite well as well. And it seems to have drawn the cart into a kind of alignment. The other side, well, it's the same story. And while screwing can't fix the flaring that we've got on our print, well, overall it does have the effect of making it feel a lot more solid in the hand. A lot more of a, well, not a product, but an item. Something that exists in the world. Something of density. Something of worth. Of value. Oh, I've got some glue on the top. Darn it. Okay, we're going to stick a sticker on there anyway. And another problem. I printed this sticker 2 days ago, although it won't seem like it in the video, and it's just been lying on the side. But it seems to absorb moisture or something out of the air and become, well, all curled up and rubbish looking. This doesn't happen with my other sticker paper. Yes, I'm not very pleased about this. I'm still going to go ahead and use it because I want the video to be congruent. I want it to be truthful as to what you've been watching. And then we run into a problem. The top sticker, well, it doesn't actually fit within the recess of the case that I've printed. But never mind. We'll stick that down and we'll go and get my trusty scalpel. Should make short work of this. What is going on? I always say that I try to stay congruent in my videos so you can see what goes right and what goes wrong, and it seems to me that everything's going wrong in this video. However, let's just soldier on with what we've done. I don't mind telling you I'm feeling a bit dispirited right now. So there we go. Built from scratch, it's our island run cartridge. What can I say? Perhaps apologies. Let's go over to the second bench where we can test on our Atari 2600 Junior. I really love this Atari 2600 Junior. I fitted it with one of the deluxe AV mods from the Future as 8-bit. It really makes a difference to the console. Link below. Oh, I'm so embarrassed. I'm so utterly embarrassed by this. I'm so sorry, YouTube. I genuinely thought this would be an awesome video, but, well, it's turned out crap. Let's stick it in the hole. Although surprisingly it does fit quite well. And I finger the self-destruct button. But instead of self-destructing, the game springs into life. Island Run. In its own cartridge. Is this a world first? Let's get the period accurate Atari 2600 joystick with the rubber cover missing. I always thought that back in the day there'd be more CX40s with the rubber cover missing than with them installed. So this is a very simple game that just fits into 4K. All you do is you jump, very much like the Mr. Dinosaur Man when you don't got no internet, or, well, any other endless runner really. Despite the lack of left and right movement, despite the collision detection being horribly unfair, and despite the fact that there's no score, so you don't even know how far you've got, there's something strangely compelling about this game, almost hypnotic. You'll play it until eventually you'll succumb to one of its really unfair deaths. Like that one. Bloody cheat. So, Island Run on the 2600. Well, I can't fault the game because it's certainly better than anything I could ever program. Can I fault the cartridge? Well, it works. The PCB's great, thanks PCBWay, but this one's one that's going to probably stay on the shelf as a symbol of my shame. A massive thanks to my amazing patrons appearing on the screen now. I really could not do this without them. And talking of patrons, over on patreon.com I've run a caption competition, and I said that the winner would be mentioned in this video. Except I can't pick a winner because they're all pretty hilarious. In fact, some of them, I can't even read them out. You'll have to go and see for yourself. I'll make that post public so you can all pop over and have a look at the caption competition, and I'll put the link in the description below. And consider becoming a member whilst you're there. I think there's even a free tier so you can follow me and look at how beautiful I am on a daily basis. Well, that's that. That's your lot. Until next time, this is Mark from Mark Fixes Stuff signing out and reminding you to subscribe to get your fix. See you on the other side. Bye.